The final synthesis, the one we call Archimede III, is occurring right now in Mexico as we are speaking, and it involves the following keywords: price, strength, modularity, ease of assembly by low-skilled crews, exportability, high thermal efficiency, resistance to earthquake, hurricanes, and sustainability. We just cannot wait to show you all the exciting models that we have in the works. This will happen very quickly as our production facilities are being set up right now. Here's why. Obviously, when you have a triangular structure, you have a lot more strength to develop than when you have a parallel structure like the one on the right. So we use a panel which in its core has a complete triangular structure of 12 gauge wire, and this structure gives strength to the wall, resistance to lateral loads like winds and earthquake loads. When finished with the proper concrete veneer on each side, it forms an incredible wall with a good insulation properties, but also incredible structural strength. Coming up in different thicknesses, this technology, which was purchased by a Mexican businessman from an American patent 20 years ago, is rapidly catching all over the world. It is both inexpensive and quite fast. The structural results are just outstanding, but there are quite a number of inconveniences. First of all, it's a highly engineered system by which the positioning of the different steel reinforcing element is critical. Let's look at the typical application that's done in the site. We try to do everything within the factory, so to avoid a lot of these operations. The easiest one, of course, is to position the elements. They're very light in weight, and once you slip them over their vertical rebars, it's quite simple to just tie them together with using pliers and twist wires. They need to be attached to each other by joining elements, which are small grids, which needs to be tied in and wire wrapped. This part can be pretty tedious. There's quite a lot of those to install, like this corner piece. We try to make as much as possible at the factory, so you don't have to do them at the site. So basically what we do is ship a much larger panel containing the windows and doors most of the time and all the connecting elements. Some of these operations are dangerous, like for instance cutting these panels with a high-speed saw in the field can cause accidents, especially if you use a low-skilled crew or young people not used to mechanized tools. This is why by doing everything at the factory like we do, we suppress all these dangerous jobs. Some of them involve positioning of precise elements at precise positions to develop the structural strength, like this header. This would be done at the factory within a jig that's very precise. Same as the positioning of this stop bar, which requires some skill. Now, a lot of these connectors require small pieces of armature which needs to be inserted. As you can see, these little vertical bars are inserted in melted areas. Now, to melt those trough, you need to use a torch. And using a torch, it can be dangerous. Can set fires, and a lot of people not experimented with could burn themselves. So this is done at the plant again. The wiring, the tubing, the plumbing material, pipes, all done at the factory from precise jigs and from precise sub-assemblies. By doing it this way, we multiply the speed of erection by a factor of 10. And the control environment of a factory makes for very precise assemblies, which you cannot always get at the site. Same goes for ceilings. Ceiling panels have to be held temporarily by shoring. These are vertical posts, and these are costly and sometimes not available on faraway sites. When we export our housing system, we use a technique by which most of these roofing timbers are part of the final structures, forming great, good-looking timbers. This is an end wall. It's done with a torch. You have to burn into the foam and then put cement with a rebar. Again, this is done at the factory. Now, this part is done at the building site. You need to keep that stuff wet for a few days. And eventually, what we do, we take a very good technology and we combine it with a Canadian prefabrication technique, and we have pretty much a perfect system, one that can weather all kinds of extremes, environmental conditions like heat and cold, earthquake. We can take a lot of axial and lateral loads of different types. We can take high wind loads, hurricanes, and also most of these houses could stand severe flooding, even tsunami conditions, as was shown with the recent tsunami in Indonesia. We can take a lot of abuse. We have a system that's non-corrodable, will resist insect, can be assembled by a low-grade, low-skilled crew very quickly, does not require a whole lot of technical support or, if you wish, technical superintendents at the site, uses local materials like concrete, which are readily available in all countries of the world, and gives a final product that is truly permanent, yet fully green in the sense that it requires much less energy to cool or to heat in wintertime, and yet provides a very attractive house that is not a prefab job, as we say, but a fully permanent house done with prefab techniques. Thank you very much. In a future video, we will show you photos of our assemblies. We are still seeking patents, and we cannot show a lot of confidential material within this video. Thank you for your patience, and please come back. Thank you.